Okay, so now we'll move to the next section of this lesson 2.5. So we are going to discuss about the variance and standard deviation. Okay, so first we are going to talk about how to find the variance. So variance, actually, what is the variance? What do you mean by the variance? So variance is actually the fact that how each data point deviates from the mean. So basically we are going to check how each data point is varying from the mean, the average, the x bar. So basically you have your x bar. So if you take a discrete data set, you have each data point. So we are going to see how each data point is varying, how much of a gap you have between the mean and the data point. So basically variance is actually showing you how much, again, variance is what? A measure of location or a measure of spread? I think you can see very clearly it's a measure of spread because it shows again how much your data is going to be spread around the mean. Okay. So this is the main equation for variance. Sigma means to add x minus x bar square. The reason they are squaring it is because some data points are below the mean, some data points are above the mean. So when you get a subtraction, some data points may give the difference positive, some may give the difference negative. So then when you square it, you will get a positive difference. So you get the difference square. The difference square you divide by n. So this is actually called the variance. So this is the co-equation for variance, and actually they have given you a more simplified version over here. Sigma x square over n minus sigma x over n whole thing square. So actually this second version is the one that we use the most. Let me write it again. Variance, let's write it down. Variance equals, the co-equation is sigma x minus x bar square divided by n. Okay, so this is the co-equation, but this can also be written as sigma x square over n minus sigma x over n, the square of the full thing. So actually, the second equation is the one that we use the most. This is the equation that we use by far the most. Okay, so but also you must know the first equation as well. The first equation is also something that you must really definitely know. And I think you can see they have given you another equation over here as sxx over n. So you might be, I think this is, you're not familiar with sxx at this point because you learn about this in chapter 6. You learn about sxx. In chapter 6, chapter 7, you learn more about these. So actually we will learn about this when we come to the summary statistics in that particular chapter. So at this point, for variance, we will be working mainly with this particular equation. Over here, I think you can see when you just have sigma x square over n. So you can see this is a discrete data set that does not have any repeated values. There is no frequency. So this variance equation has to be used for a data set that does not have any frequency. So this is not used for a frequency table. This is used when you have the data set given to you, straight given to you with commas, like they give you each data point individually. Okay, so that is used, this particular equation must be used in that instance. Okay. So, okay. And also let's define one more person. The next important person is standard deviation. So this is the really important person. Standard deviation also denoted by this sigma sign. Okay, also denoted by the sigma sign. So standard deviation is called as the square root of variance. Okay, the square root of variance. You do realize to get the variance, we squared each and every, the difference between each and every data point with the mean, right? We squared it and we got the variance, isn't it? So then standard deviation, you actually square root it. Okay, so standard deviation is actually the most important unit that we will be using for further calculation. So how do we calculate standard deviation? By taking the square root of variance. So basically, sigma x square over n minus sigma x over n whole thing square, and you square root it. So this is the standard deviation, the sigma. Okay, so you can use this equation when it comes to a discrete data set like this. Actually, this equation works for discrete data sets, right? Because you have individual x values given to you. Okay, so let's use this. So I have the individual x values given to you. There are 10 individual x values over here. Shall we find the variance and the standard deviation? So to find the variance and the standard deviation, children, you need to first find. Now also bear in mind, though for variance, we have two equations. We are mostly using the second equation rather than the first one. Okay, we are mainly going with this because it's easier to find values with this. Okay, so let's get the first one that you need to find here is what? There's something called sigma x square. What do you mean by sigma x square? Sigma x square is where you take each and every individual x value and you square it. So who is the first x value? 10, you square it. And what's the meaning of sigma? Sigma means to add. So 10 square you add with 12 square plus 12 square plus 14 square plus, like this goes on until where? 25 square. So you have to keep squaring each and every individual x term and you have to add it. So sigma x square is 3052. So you type this in the cal and the next value is sigma x. Sigma x over n whole thing square. But before we go for that, we need to find sigma x. Who is sigma x? Sigma x is what? Simply add all the x values. 10 plus, 12 plus, 12 plus, 14 plus. You keep on adding all the x values until 25. Add each and every single individual x value. That is called sigma x. So sigma x, when you add everything over here, it becomes 168. So now shall we get the variance? So variance equation, write down. You need to write it and practice because this is not something given to you in the formula book. Sigma x square over n minus sigma x over n whole thing square. So it's writing that gives you the practice here. Sigma x square is 3052 over n is how many data points you actually have. How many data points do you actually have? You have 10. Minus sigma x is 168 over n is 10 whole thing square. How much is it? So the answer is 22.96. So I get the answer as 22.96 for the variance. So this is my answer for the variance. Can I also have the standard deviation? So standard deviation is actually the person who shows the real deviation from the mean. What is the standard deviation? Square root of variance. So square root of 22.96 is 4.7916, which is 4.79. So actually the standard deviation is the more important unit when it comes to both of them, because as I told you, variance gives you the square, right? The variance gives the square of the differences. But standard deviation will square root this square of the difference, so which gives you like actually how much the data is spread around the mean. So the standard deviation is what gives you the proper deviation around the mean. This is clear. So standard deviation is what actually shows you how much the data is actually spread around the mean. Okay, because variance gives you a square unit, while standard deviation gives you the proper deviation. That's why they use the word standard deviation. So this is the deviation and it's the standard one. Okay, that's why it's called the standard deviation. So it's the standard amount that the data points, how they are spreading around the mean. Okay. Okay, so now we come to the next part where you actually work with frequency tables. So frequency tables are there for discrete data as well as continuous data. So frequency tables are there in discrete data as well as continuous data. So this should work for discrete as well as continuous as long as it's a frequency table. These are the equations that we are gonna use. Okay, so basically the variance equation, let's write down the sigma square. Variance also called as sigma square. Okay, over here also variance is also known as sigma square because square root is the standard deviation. Okay, so variance also known as sigma square for frequency tables. So this is actually not the most popular equation. X minus x bar square you multiply with frequency divide by sigma f. So this is not the most popular equation. We are mainly using for sigma square. So this is the main equation, sigma fx square over sigma f minus sigma fx over sigma f whole thing square. So this is the main equation that we are going to use. Let's use this. Okay, so this is the main equation. Okay, and once again, the sigma is the standard deviation. Sorry, sigma square does not have the root, isn't it? Sigma square does not have the root. That is the variance. The variance doesn't have the root. Okay, sigma square is the variance, sigma fx square over sigma f over sigma fx over sigma f whole thing square. Standard deviation is what? Square root of variance. So if standard deviation is square root of variance, then you square root the whole thing. Standard deviation is what we call as sigma. So that will be the one where you apply the square root.